Thank you, Jerry, and thank you once again, NewEra Software, for sponsoring these crypto sessions. This month, October, we're going to talk about crypto and disaster recovery. Now, this topic has gotten a lot simpler since the last time I presented it, because in the past we had the old CCF-based machines that we had to consider. And if you remember when we talked about the hardware in February, the CCF-based architecture, the architecture that was available on the Z800s and the Z900s and earlier machines was very different than the architecture today with the CPAC-F and the Crypto Express cards. So it's a little bit simpler. However, there's still a lot of variables involved in terms of disaster recovery. There's a lot of things that you've got to consider, and we'll get into those in a minute. And the other important point that I want to kind of hit on throughout the topic today is normally when you're looking at a DR exercise, and especially the test, you're looking at exercising the functionality and making sure that your DR site can handle all of the work, all of the different types of work that are run on your production system. But with crypto, I think more than other areas, you've also got to consider the performance aspect at your DR site. We're going to talk in a minute about, the possibility that you might have different configurations at the DR site versus what you have at production. So you might have fewer hardware devices, crypto hardware devices. Or you might even not have the same crypto hardware. And as if you remember in some of the other topics that we've talked about, there are cases where the software will get involved and perform cryptographic function. So maybe if you don't have a Crypto Express card, you can still do System SSL work. It's just done in software. Now, if you're planning on running your production system at the DR site and you're going to be doing System SSL, but you don't have the crypto hardware to support that, the work's still going to get done, but the performance is not going to be anywhere near what you need to accomplish your DR environment. So as we go through this discussion today, keep in mind that you've also got to think about those performance considerations. And it's not enough just to make sure that the crypto works, but you've also got to have an understanding of how much work you've got and whether you've got sufficient crypto resources at the DR site. So with that, let's go to slide 2. And this is kind of a summary of what we're going to do today. So, like I said, there's a number of variables involved, and one of those variables is how do you do your DR? Do you run a hot site or a cold site or a warm site? How are you restoring your environment? What data are you encrypting as you take it to the DR site? Are you encrypting your res volumes and your catalog volumes, or are you only encrypting application volumes? Or are you only encrypting specific data that has PCI or healthcare data or HIPAA data, whatever, in it? And so you're focused on only encrypting absolutely what needs to be encrypted. So we're going to talk about some of those variables. We're going to talk a little bit about master keys. We really talked about that a month or two ago and loading master keys. So we'll come back and touch on it a little bit, but the more important aspect of the master keys is at what point do you need to load those master keys at the DR environment? And that goes back to that discussion of whether you're running a hot site or a cold site or a warm site. And then we'll talk in some more detail about the possible options for what data is being encrypted. Are you using the encrypting tape drives? Because if you are, then there's some considerations of making your key stores available at the DR site. Whereas if you're using the encryption facility or one of the OEM products, you might have to have those key stores available, but maybe you could use other techniques, and maybe the key stores aren't as important depending on how you're doing that. And then finally, we're going to talk a little bit about the TKE, the Trusted Key Entry Workstation. We introduced it back in March when we talked about the hardware. There are some ways and some things that the TKE can do for you in terms of easing the disaster recovery process. So we'll talk about the TKE and how it could play there as well. Let's go to slide 3. So again, one of the first things you have to consider is how are you doing your DR? Are you running a hot site or a warm site? If you're doing a hot site, then you're going to be mirroring your DASD, and there's some considerations there when you get the master keys loaded and exactly how much of the data is being encrypted and is secure as it moves from production to the DR site. But even more basic than that, you also have to consider the hardware platforms that you're running on. And the reality is, even if you're running identical hardware in production and DR, maybe you're running a zEC12 in production and you have a zEC12 at your DR site, if they're not identical down to the microcode level, then there's a possibility that you could have functionality at the production site that you don't have at the DR site or vice versa. So a more likely scenario is that the DR site and the production site are going to be different in terms of the platforms. And then you could have either possibility. The DR site could have newer technology than you have in production. Maybe if you go to a business partner to provide the DR platform, you might be running a Z196, fairly current technology, but they may have zEC12s installed at the DR site. So you're going to go to newer, faster, smarter technology at the DR site. And there's some considerations if you do that. Or on the other hand, you might have older technology at the DR site. If you are your own DR provider, what some shops will do is as they migrate to a new architecture, a new platform, as they go to a zEC12, they might take the Z196 that they were running in production and move that to the DR site and let that become their DR machine. Now, in that environment, you're going to be running on the latest and greatest technology. And if you're taking advantage of that new capabilities, the new functionality that's available on the new architecture, when you go to the DR site, those new functions may not be there. So you've got to worry about that and make sure that whatever functionality you need at the DR site is there. And then down at the bottom, we're going to touch on using virtual machines for DR testing. Um, you're not going to run a DR. You're not going to recover your disaster. You're not going to have your disaster recovery environment running on virtual machines. However, there are some cases where, especially when you're first setting up your DR environment, your DR provider might give you a virtual guest to just make sure that you've got all of the pieces, all of the components, the functionality. Now, certainly you can't do that in a true DR because it probably wouldn't give you the performance you need, but we'll at least touch on things you've got to think about if you're using a virtual machine to get your DR environment up and running. So with that, let's go to slide 4. So the next two charts, or these two charts, are kind of my rainbow charts. They've got a lot of different colors on them. And what I'm trying to highlight here is that every new architecture has new functionality. So you've got to worry about, do I have the right functionality at the DR site to support the work that I'm doing on the production site? So, going back a ways, on the Z890s and the Z990s, they only supported DES encryption and SHA-1 hashing. That's all that you could do on the CPAC-F hardware on those machines. If you were running those at your DR site and you had a Z9 or something later in production, well, on the Z9, you added support, or IBM added support for AES encryption. And if you were starting to take advantage of AES encryption in production, then you wouldn't have that hardware support at the DR site. Now, it turns out that ICSF does support AES encryption. It has some software routines that'll do AES encryption for you if the hardware is not available. So if you took that AES workload from your Z9 in production and tried to run it at the DR site, it's going to run in software and it's going to run a whole lot slower than it would at the production site. And if you've got to support any kind of volume, that could be an issue. Protected key architecture would be another example. With protected key, that was introduced with the GA3 of the Z10 machines and the Crypto Express 3 cards. If you implemented protected key work in your production environment, you would have to have at least a Z10 GA3 with Crypto Express 3 cards at the DR site to be able to support it. There is no software support there. So if you didn't have at least that same level of architecture at the DR site, that protected key workload is going to fail at the DR site. The latest example is the new chaining functions that were implemented on the Z196. If you remember back when we talked about the hardware, we talked about this capability. The chaining provides cipher block chaining, which provides better security for your crypto data. If you remember, we had a picture of Tux the penguin that had been encrypted using just routine encryption, and you could still see the shadow of Tux. But when you introduce cipher block chaining, the image was completely just random numbers, and you couldn't see Tux at all. So with that hardware support, what was going on is the CPAC-F hardware will perform cipher block chaining. Prior to that support, ICSF would get involved and do the cipher block chaining with it was still called the hardware, but ICSF was getting called to pull some of the intermediate results off and pass it back through the hardware again. So once again, that's another example of if you took that workload to a DR site on an older machine, it would still work, the work would still get done, but the performance might not be acceptable in that environment. So you got to think about that, and you've got to make sure, do I have the functionality and do I have the capacity at the DR site to be able to support the workload that's running on my production environment? And then the last thing on this chart, don't forget that the crypto enabling microcode, that's feature code 3863, has to be installed at the DR site to enable the crypto hardware. We talked about it before. That's not as big a deal these days. Most shops just routinely go ahead and get the feature code and install it because virtually everybody's running at least some level of crypto workload. But when you go to your DR machine, you've got to have that crypto enabling microcode. Otherwise, the hardware isn't going to do you any good at all. So with that, let's talk about the Crypto Express cards on slide 5. So you've got a couple different possibilities in terms of the relationship of the hardware levels at the production site versus the hardware level at the DR sites. You could be running the same KEC levels at both. You could be running newer hardware at the DR site, or you could be running older hardware at the DR site. And each of those have their own kind of special considerations. If you're running the same KEC levels at both sites, then you're probably not going to have any issues. However, there's a slim possibility that um, the DR site maybe doesn't have all of the latest and greatest MCLs. Those latest and greatest MCLs might introduce new functionality. Now, the chances of you implementing and actually using new functionality that quickly is probably pretty slim. It's going to have to work through your application developers are going to have to implement it within their code and take advantage of it. So for the most part, as long as you're running the same KEC levels, you're probably going to be safe, but you're going to need to test just to be sure. What's more likely is that you're going to be running different KEC levels at the two sites. So what if the DR site has the latest and greatest hardware, newer hardware than you have in production? From a functionality perspective and from a performance perspective, you're probably safe there because that newer technology can do everything that the old technology can do, and it can probably do it a little bit faster. However, you do have to worry about the possibility or the need for installing toleration maintenance on your production machine. So, for example, if you've got, let's say you're running a Z196 with Crypto Express 3s in production, your DR provider is going to give you a zEC12 with Crypto Express 4Ss. And let's suppose you're running a little bit older version of ICSF, maybe HCR 7790. Well, 7790 does not know what a Crypto Express 4S is. So if you pick up your production operating system and drop it down on that zEC12 and with the Crypto Express 4S, it's not going to know what that hardware is, and it's going to fail when it tries to use it. There is toleration maintenance that you're going to have to get installed so that it will recognize that Crypto Express 4 and treat it like a Crypto Express 3. So you don't really need the toleration maintenance at your production site, but you've got to have it on that production system so that when you pick it up and carry it over to the DR site, it'll be there and you won't miss a beat when you start running it on the DR environment. And then the other possibility is if the production system is more current than the DR site. So you're running a zEC12 in production, maybe you've got a Z196 at the DR site, then it's back to that issue or that question of, are you taking advantage of any of that new functionality on the Crypto Express 4s, on the EC12 in production? Because if you're using that new functionality, it's not going to be available at the DR site, and once again, that's going to fail if you try and run on that old hardware. So the reality, like with even running the same machines with different MCL levels, it takes a while for new functionality to get implemented. It depends on how long you've been running on that new hardware and whether you've actually been implementing some of that the new capabilities. That's what you got to worry about. So you got to really know what your people are doing, what the applications are doing, and it boils down to you got to worry about testing and making sure that everything works when you get to the DR site. So with that, we're going to go to slide 7 and start looking at some of the more operational aspects of setting up the DR environment. So at your DR site, it's highly likely that the hardware configuration is going to be different from your production environment, especially if you go to a DR provider like an IBM or a SunGard. You may end up using different cards there than what you're using in production. So for example, in your production environment, you might be using the cards in slot 6 and 7, like it shows on this slide, but your DR provider might assign you cards 8 and 9 in the environment that he provides you. So that's probably not a big deal. That happens within the LPAR activation profile. Those devices are going to get assigned. Now, there's also a possibility, depending on how your contracts word it, you might have more devices available at the DR site. That's probably a good thing. It's a possibility maybe you have fewer, or even if you have the same number of devices, if you're running on different levels of technology, that possibly could be an issue as well. So, for example, if you're running Crypto Express 4S's in production and you've got two assigned, and you go to the DR site and they assign you two Crypto Express 3s, well, the Crypto Express 3s don't have quite as much capacity as the Crypto Express 4S. So if your production system was running full out and fully utilizing those two cards, there's a possibility that two Crypto Express 3s at the DR site might not be sufficient. So you maybe want to have an additional engine available in that case. The other thing you have to worry about is the control domains. Well, we're going to talk about the usage domains on the next slide, but if you're using a TKE, which we're going to talk a little bit more about at the end of this discussion, you also have to worry about making sure that the control domains are assigned properly. The control domains manage and provide the TKE access to other LPARs and other usage domains on the cards, so you can manage across multiple LPARs. And you'll just need to make sure that those are configured properly as well. So let's talk a little bit more about the usage domain on slide 8, because that could become a bigger issue. So if you remember, the domains cannot be shared between LPARs. You assign the usage domain in the LPAR activation profile, and then when an LPAR is activated, it'll grab the domains that are assigned to it, and nobody else can have those domains. And if you remember, we talked about the fact that if you only assign a single domain in the LPAR activation profile, ICSF is smart enough to figure out when it starts that, hey, I've only got one domain, I'm going to use it. So there may be some additional steps you have to perform when you move your production operating system to your DR environment. So let's suppose that on your production system at home, you're running with no usage domain assigned. So in your ICSF options dataset, you don't specify the domain parameter, and ICSF will figure out, hey, I've only got one assigned, I'm going to use it. When you get to your DR environment, maybe your DR provider gave you two domains to give you some flexibility, and maybe he assigned usage domain 3 and 4 to the LPAR where you're going to build your DR system. In that case, when you don't specify the domain in the options data set, ICSF doesn't know which one of those to use, and ICSF will not initialize. So you're going to have to go in and change the options data set when you get to the DR site to say, all right, today we're going to use domain 3. Now, in your production system, maybe you're assigned domain 6 and 7 to your production environment, and your options data set specifies, has a domain equals 6 parameter in it. Say, okay, we're going to use domain 6 for normal operation. At your DR site, maybe your DR provider gave you domains 8 and 9. Once again, you're going to have to go in and change that options data set to tell it, okay, instead of using 6 like we do in production, today we're going to use domain 8 at the DR environment. And then we're going to talk next about the VM directory. You've got the same issue when you get into the VM directory. You've got to define those domains and make sure that they're available to the guest, and then that's going to have to match the options data set as well. So let's go to slide 9 and talk about VM. So again, you're probably not going to run a DR environment as a VM guest, although some of your initial testing for functionality might use a guest. If you do, then just like you have to assign the hardware via the LPAR activation profile, if you're running a VM guest, you've got to assign the hardware devices to the guest. You do that in the VM directory with the crypto statement. Now, the documentation is a little bit hard to understand. There's two types of coprocessor devices defined in VM. There's AP dedicated, which the documentation talks about coprocessors, and then AP virt or AP virtual is for the clear key devices, the accelerators. Well, it turns out from a ZOS perspective, you will not use AP Virtual. Even if you have accelerators defined in the hardware and the devices are configured as accelerators on the KEC, you will assign those using the AP dedicated statement, not the AP virtual statement. The documentation does talk about the fact that AP Virtual is only for Linux and VSE guests. It specifically says it's not used with ZOS, but it doesn't really come out and tell you that you have to use AP Dedicated for those accelerators. So again, the crypto statement is just going to assign which engine. So let's suppose in the LPAR activation profile, engines 6 and 7 or in slots 6 and 7, AP 6 and 7 are assigned to the LPAR. Then in the crypto statement, you would say crypto AP dedicated 6, 7, and that would assign those two engines to this particular guess. Or maybe you assign AP dedicated just 6, and only engine 6 is going to be available to this guest. And then on the same statement, you would also specify the domain parameter and tell it which domain on those cards it's going to use to when it needs a master key or when it needs access to the master key registers. And then down at the bottom, there is another statement, a cry measure, which will give you some performance data. I don't think you really care about that in the DR environment, but it's there if you want to use it. So now we're going to turn our attention a little bit more to the actual process for restoring the environment. Let's go to slide 10. Before we actually talk about restoring the DR environment, keep in mind that you are going to have to load your master keys at the DR site. At some point in the process of building that environment, whether it's part of the driver system or the actual DR system up and running at the production site, you're going to have to load the master keys. And as we discussed a couple months ago, whatever procedure you used in production, you're going to have to use that same procedure at the DR site. So if you use PPNet, passphrase initialization at the production site, that passphrase is going to have to be available at the DR site. If you use the ICSF panels and multiple key parts, those multiple key parts are going to have to be available at the DR site. So one of the questions that we get is that do I have to have all of my key officers at the DR site? Do all of my key officers have to get on and do their thing? So from if it's a true disaster, the goal is to get the system up and running. And if you've got 3 or 4 key officers, they're dealing with a disaster too. They may not be able to get to the DR site and be able to do the loads and all. So to really get up and running, I think it's acceptable to maybe just have one key officer open up the envelopes and load the multiple key parts. Now you have to clear that with your security folks and you clear that with your auditors and all. And from another perspective, what better time to have a breach of the system if you give one key officer access to all the key parts. Now they have the keys to the kingdom, so maybe that's not acceptable. But again, if it's truly a disaster, the goal is to get the system up and running quickly, and maybe you just let one key officer perform the key loading process. Also keep in mind that like when we talked about or loading the master keys a couple months ago, once you load the master keys into the hardware, there's no way to retrieve those key values. So you've got to have that well-documented procedure that says, here are the envelopes with the key parts. Here's how we know that we've got the right master key. We talked about writing the hash value of the master key on the outside of an envelope that contains the other key parts. So if there's any confusion at the DR site, you can dump the header records in the key stores, see what the hash patterns are, and then find the envelope that matches those, open up those envelopes, and you've got the key parts available. So let's go to slide 11 where we actually start talking about restoring the DR environment. Now, the other consideration or the other issue here is how you're going to restore that DR environment. You've got a couple options. If you're running a hot site, you're going to be doing DASD mirroring. And so as you make changes on the production system, that's going to get mirrored to the DR system. So if you change your master keys in production, you're going to have to load those same master keys pretty shortly thereafter at the DR site, because as the data gets encrypted using the new keys, or the keys are re-encrypted, you're going to have access to them at the DR site. So that's probably going to have to happen very quickly. If you're running either a warm site or a cold site, then probably what you're doing is you're dumping your data to tape, and then carrying those tapes maybe directly to the DR site, or maybe they're being stored in Iron Mountain. So in that environment, you're not going to load the master keys until a little bit later. And in the next couple slides, we're going to talk about some of the tools that you can use to do this. But you're not going to need to load those master keys until you start restoring the environment at the DR site. So maybe you want to make sure that those key parts are stored with the backup tapes that are going to eventually be used to recover the environment. And then we're going to talk a little bit more about, exactly how much data you're encrypting as you create those backup tapes that would be used at the DR site. Are you encrypting everything? Are you encrypting your system volume, your res volumes, your catalog volume? Or maybe you're only going to encrypt the application data. Kind of one of the things that I recommend, and I think you've heard this from me before, is you really only want to encrypt what has to be encrypted, because encryption takes up resources. It uses up CPU cycles if you're doing it using software. So it makes some sense to only focus on the data that needs to be encrypted, not to encrypt the res volumes, not to encrypt the catalog volumes or the page volumes, not to encrypt the key store, because the keys are already encrypted in the key store. So let's go to slide 12. Okay, so I've gotten a little bit ahead of myself in talking about, exactly what data you're encrypting, but, maybe you're going to encrypt the application volumes, that is all of the volumes that have application data on them, or maybe you're going to encrypt just specific application data, the specific data that needs to be encrypted, that has credit card information in it, that has HIPAA data in it. You've got a couple different choices in terms of how you do the encryption, and how you perform the encryption. Again, the encrypting tape drives are the most efficient way to handle encryption. They only have about 1% overhead in performing the encryption, and that's on the controller. That's not on the CPU, so it's not using up CPU resources. So my recommendation is use the encrypting tape drives. That's the most efficient way possible. However, we still do have some customers that are using software encryption, products like the encryption facility for ZOS, and some of those customers are encrypting everything. That is, they're encrypting their res volumes and their catalog volumes, as well as all of their application data. Now, their logic is, if we have a loss, if we lose a tape, if the shipping company comes to us and tell us, there's a tape missing, it fell off the truck, they can take the position, well, we encrypt everything, so we don't have to worry about going through PCI notification. We don't have to worry about letting people know that the data was lost, because it was encrypted. And some of those customers, they have the spare cycles available. Maybe they're not fully utilizing the machines on the weekend, so they'll take those that white space, those spare cycles on the weekend, and use that to perform the encryption to protect their data. Now, with each of these, you have some considerations in terms of how you're going to make the key store available. If your keys that encrypt the data, whether it's on the tape drives or whether it's using the encryption facility or an OEM product, if the keys are in a key store, then you've got to make that key store available to the driver system, or to the system, so it can perform the recovery. So with that, let's turn to slide 13. So again, there are a couple ways to do it. I recommend that you use the encrypting tape drives because they're the most efficient. Now, when you're using the encrypting tape drives, what's going on here is the data on the tape is actually encrypted using a symmetric key. But that symmetric key itself is encrypted using a public-private key pair. And that encrypted key is stored on the tape. So when it gets to the DR site, the public-private key pair needs to be available so you can decrypt the symmetric key and then use that to decrypt the data. Now, with the encrypting tape drives, with the IBM encrypting tape drives, there's another software product involved. The IBM Security Key Lifecycle Manager is the name today. It's also been known as TKLM or EKM in the past. And that software is basically just a traffic cop that provides the communication between the tape drive and the key store. And you can have your key store in a couple different places. You can use RACF as your key store. You can use ICSF as your key store, or you can use a combination of both RACF and ICSF as the key store. So if you're using RACF, your public-private key pair is actually stored in the RACF database. So when you dump your system, when you dump the res volumes and the catalog volumes and the RACF database and carry that to your DR site, you can restore those. But you're going to have access to the RACF database when you start restoring it. So your driver system is going to have access to the RACF database so you can recover the key material and use that to decrypt the rest of the data on the tape. If you use ICSF as your key store, just ICSF, you got a similar situation. Your PKDS is going to have to be available to the driver system, the system that's actually going to restore your dumps from tape to the DASD volumes, so that the key, the RSA private key that will decrypt the symmetric key off the tape is available. And then if you're using RACF and ICSF, you're going to have both of them available. The certificate information is stored in the RACF database, but the actual key value is going to be stored in ICSF, just as if you weren't using RACF, if RACF wasn't involved at all. So in that environment, you've got a little bit better security around the key store, but it does mean that you've got to make those RSA keys, either the RACF database or the ICSF PKDS, available to the driver system so he can actually perform the restore. And in a lot of DR environments, the DR provider is going to give you a driver system, and you can just point that to the appropriate RACF and or key stores. So let's go to slide 14. You can also use a Java key store. ISKLM, instead of talking to a ZOS system and with RACF or an ICSF, could actually talk to another system that has just the Java key store on it. The same thing. He's going to talk to the key store, get the key material, the public-private key from the key store, use that to decrypt the symmetric key on the tape. Now, that kind of implies, and in both cases, that ISKLM needs to know where that key store is, needs to have the IP address, needs to have the proper configuration so he can access that system. And you've also got to worry about, if you're using ICSF or RACF, then you're going to have access to that outside of the system environment. And with the key store as well, you've got to know where this system is sitting, where the IP address is, so he can communicate with it and get that key material to do the decryption of the symmetric keys. Let's go to slide 15. Now, if you don't have the encrypting tape drives installed and available, then you can use software encryption to encrypt your backup tapes. One way to do that is with the encryption facility for ZOS. There's a feature, the DFSMS DSS feature, that basically provides some additional functionality within DFSMS DSS to encrypt the data as it's created. or as it's dumped. Now, there's a couple options there. The password option, you basically just change your DFSMS DSS control statements and specify a password or a passphrase, and it will take that passphrase, hash it, and pull some bits and bytes out of that hash to be your symmetric key that actually encrypts the data. The downside of using the password option is that passphrase is probably going to be hard coded in the control statements. So if somebody can get access to the control statements, they can see what the password is, and they could theoretically perform the same hash calculations and come up with your key value. A better option is to use the RSA option. And when you use the RSA option, what happens is DFSMS DSS will work with ICSF to generate a random number that will actually be used to encrypt the data. That random number, in turn, will be encrypted under a public-private key pair and stored in the header record as part of the dump. And then when you perform the restore, then that public-private key will again be used to decrypt that symmetric key that's in the header record on the dump tape, and use that to recover the data. So that's much more secure, but the implication is that public-private key pair has to, or the private key is going to have to be available at the DR site so it can decrypt the data. So if you're using a driver system at your DR site, that driver system is going to have access to your PKDS so it can get to that private key and perform the encryption of the decryption of the symmetric key. Now, you've also got a couple options in terms of how you encrypt the data on the tape. You can use clear key encryption. So you can use either clear key AES or clear key DES. The reason I mentioned clear AES on here is if you've got older technology, maybe that didn't support AES encryption, then in that case, ICSF will actually jump in and handle the AES decryption for you, encryption and decryption, which is not going to be nearly as efficient as having the CPACF hardware available. That's probably not a big issue today because it was only the Z890s and the Z990s that did not support a clear key AES. Or you can use secure key, specify the encrypted TDES parameter. That tells ICSF to use the secure key hardware. And once again, if you've got secure key hardware in production, and that's what you use to encrypt your backups, you're going to have secure key hardware at the DR site to be able to use that option. And if you're using the RSA option, like we described before, and storing your keys in your PKDS, you're going to have a Crypto Express card anyway to even have the PKDS. So let's go to slide 16. The other option, there are some other OEM products that work kind of like encryption facility. So ASPG, FDR, the other one is CopyCrypt. Those can also be used to encrypt your backups. Now, most of those products, and you really need to talk to those vendors, but most of those products, as I understand it, can use the CKDS or the PKDS as a key store. Again, if you go that route, those key store data sets are going to have to be available to the driver system when you perform the restores. Alternatively, I believe those products can also use their own internal key stores. And so you're going to have to understand what the options are with the product. Just keep in mind that if you use that internal key store, that's probably not quite as secure as using the ICSF, CKDS, and PKDS to protect your keys. Let's go to slide 17. So let's talk about the TKE a little bit because that does provide some capabilities in terms of being able to manage your DR site, make the process of getting the crypto configuration at the DR site set up. So the first thing to realize and understand is that the TKE level or version is associated with specific levels of KEK hardware. That is, TKE version 7.2 or version 7.3 can support the latest crypto hardware. It can support Crypto Express 2s, Crypto Express 3s, and Crypto Express 4Ss. However, the previous version, TKE version 7.1, did not know what a Crypto Express 4S and cannot manage Crypto Express 4Ss. So if you've got TKE version 7.1 installed in your production environment and managing your older Crypto Express cards, everything's running just fine. But if you try and connect that TKE to your DR environment, where your DR provider is giving you a ZEC12 with Crypto Express 4Ss, then you're going to have a problem. So the idea to keep in mind is that you've got to make sure the TKE is current enough to manage both your production and your DR environment. Now, the next issue is the fact that where do you locate your TKE? Um, the TKE is going to talk to those CACs just using an IP connection. So your TKE can physically be located anywhere you want. For example, you could have your production CAC in Miami. You could have your DR environment. Your DR provider might be in Minneapolis, so they're well spread, and it's unlikely a single disaster will take out both of them. And then you could put your production TKE on the West Coast, maybe in LA, and your DR TKE on the East Coast, maybe in Washington D.C. And you're pretty confident that a single DR event is not going to take out all of that in one shot. Now that's probably overkill. That disbursement or that big a spread is probably not what you need. But the reality is you probably do want to have a DR TKE. Let's go to slide 18. So even if you don't have a disaster, if your primary TKE, the hard drive fails, you're going to need access to a backup TKE to make sure that you can access and manage the production environment. And prudence would indicate that it probably be located separately from the production TKE. Now, maybe you go ahead and put the production TKE on the production floor, and normal operation, 99.9% of the time, everything is going to be up and running and fine. And then if and when you have a disaster, maybe your backup TKE is not co-located with your DR CAC. That's perfectly acceptable. You just have to make sure that the IP configuration is handled properly on both machines so that you can switch that IP connection and point to the DR system. So let's go to slide 19. So let's talk a little bit about the TKE that will be your disaster recovery TKE. Over on the right, the first thing is that you probably want that TKE to be at the exact same level as the production TKE. That is the same hardware, the TKE 7.3 in both sites, and even down to the MCLs that are installed on the TKE. You can get away with different hardware levels on the CACs, having Crypto Express 3s and Crypto Express 4Ss, Crypto Express 3s in production and 4Ss in DR. But the TKE really needs to be identical, and backing it up and rebuilding that DR environment is much simpler if that's the case. There are some utilities available on the TKE, so you can copy selected files. We're going to talk about key files in a minute. You can use those utilities to actually copy that data and move it over. From the host perspective, the TKE actually talks to a started task called the catcher, or a host transaction program that's running on the host. There's a DD card in that started task that points to a crypto module data set. That crypto module data set has information about the hardware and the CAC hardware environment, the cards, the slots, and the levels and all. So when you dump your production environment, you're going to dump that crypto module data set. That's going to get carried to your DR site. But because those hardware devices are going to be different at the DR site. The first time you bring up the host transaction program, he's going to rebuild that crypto module data set. So it's going to get carried over, but it is going to get rebuilt to match the DR environment. And then the other thing that we've already talked about is you've got to make sure that the configuration is set up properly so that you know when you build your DR environment, you're probably going to have to change the IP addresses so that it knows that you're talking to the DR TKE as opposed to the production TKE. So there'll be some configuration steps there that you have to perform as part of building the DR environment. Let's go to slide 20. So one of the things you're going to use for the TKE for is to make the key material available. So when you create your master keys on the TKE on the production system, you can store them in files or you can store them on smart cards. Either way, whatever you choose, you're going to have to make a copy of those keys. You're going to have to make a copy of the DVD that you can carry to the DR system. If you're using smart cards, you're going to have to clone the smart card and carry that to the DR system. So as you're defining these keys and creating these keys, that's one of the things you're going to have to manage is knowing which keys you've defined and created on the production system so you can carry those over and make them available at the DR system. Now this really applies mostly to master keys and signature keys. The operational keys, when you create a key and multiple key parts and load them up and create an operational key on your production system, that's going to get loaded in the CKDS and the key material is going to be in the CKDS. So you don't have to worry about carrying those over to the DR system. The master keys, like we've talked about before, you're going to have to make them available at the DR site. So you're either going to have to get them stored on the DVD or stored on a smart card, and then you're going to have to make a copy of that DVD and carry it to the DR site so you can use it there. Like we talked about when we talked about loading TKEs or loading master keys 2 months ago, you're probably going to have that smart card at the production system. So if you have a hardware, problem, if you have to add another device, you can quickly load those master keys from the smart card. You're going to have another copy that's available to carry to the DR site because if the production floor gets wiped out and those smart cards aren't available, if you don't have those key parts to load at the DR site, you're going to be out of luck. So you're going to have multiple copies of the master keys and the signature keys available on or to the TKE at the DR site. Let's go to slide 21. In version 6 of the TKE, IBM added a new capability called the Migration Wizard. And really what the purpose of the Migration Wizard is to help you migrate to newer hardware. That is, if you're up and running on a Z196, you can run the Migration Wizard. It'll go out and look at the host configuration, capture information about the host configuration, store that into a file. Then you can carry that file over and push it to your new machine, maybe a ZEC12, and quickly rebuild the configuration on the new machine. Well, it turns out that can also assist in a DR environment. So you can capture information about your production environment and then push it to your DR environment. And then starting with version 7 of the TKE, there was added support there, so it can also capture the master key information from your production environment. And that makes it much simpler to load those master keys into the DR hardware as part of the building the DR and building the TKE on that machine. So the Migration Wizard can help you with migration to new hardware or in a DR environment as well. And let's start wrapping things up on slide 22. Couple things to wrap up here. One of the questions that comes up occasionally is when I finish a DR, do I need to clear my master keys out of the hardware? Now, the reality is you can't really extract the master keys out of the Crypto Express card. Yes, that Migration Wizard will pull them out, but the way the Migration Wizard works, you have to have the appropriate signature keys available or you can't use those master keys that have been extracted. Without the TKE, there's no way to go in and look at the contents of the master key registers and see what your master keys are. So if you don't clear them out on the DR site, you're really not in a lot of danger. You're not in any jeopardy of having somebody compromise your master keys. However, auditors like to have a step that says we cleared the master keys out. And if you're using, what you can do at your DR site is simply change your master key twice at the end of the DR exercise, change it to a dummy value. If you remember when we talked about loading the master keys, when you load a master key, the current master key gets pushed to the old master key register. Then you load a master key a second time, and now what you load the second time is going to, or what you loaded the first time is going to get pushed and overwrite your master key that was now in the old master key register, and that effectively clears out your master keys so they're no longer in the hardware. You don't have to do the re-encipher process. You just need to do to load a master key, change the master key. You're going to get some errors that ICSF says the master keys don't match. That's okay. Just change them again, and that's going to clear that old master key register out. The other thing that you might want to consider, and I hinted at this before, is when you finish your DR exercise, when you go back to your production shop and you're running, life has returned to normal, maybe that's a good time to change your master key. If you need to do it on a periodic basis, if you do a DR exercise once a year, maybe that's the right time to change the master key, because when you loaded your master keys at the DR site, there was a chance that maybe somebody was looking over the key officer's shoulder when he loaded that master key material. And maybe he took notes about what the key parts were that were loaded. So maybe that's a good time to perform your routine master key change. And you can say, hey, we do it on a year. Our policy says we do it on a yearly basis, and we do it the week after we do a DR exercise, so that if the master key got lost or got compromised while the envelopes were open at the DR site, hey, we've changed it and now we've moved on from there. Let's go to slide 23. The other thing that I want to emphasize quite a bit is that you really need to know what's running on your system. You really need to know how you're using your crypto. If you're just using system SSL, then you're using mostly the hardware for the performance. You're not as worried about key material. But you are worried about performance and making sure that you can handle the crypto workload at the DR site, whatever level you need to support at the DR site. For products like the data encryption tool for IMS and DB2, you need to understand, are your users relying on that, because it relies on keys being in the key store in the CKDS. You got to make sure you have the integrity of that key store at your DR site. If you're using, this slide should probably be updated. It talks about the encryption key manager. ISKLM and TKLM are the later versions of that. If you're using those products, you need to understand that, because that's going to affect how you make the key stores available to the driver systems at the DR site. So the bottom line is you're going to have to test all of this stuff. You've got to know what the products are using crypto, and make sure all of those products get exercised as part of your DR exercise. And then you also have to consider the performance implications. Now, it's hard to understand, or it's hard to know what your users are using. You can have stealth users with crypto. People can go write assembler programs and invoke the KM or KMC instruction, and it would be really hard for you to know about that. But you got to keep your ear open, keep in contact with your users, understand what they're doing, and then the bottom line is just test it and make sure you're ready for whatever they bring to the table. Let's go to slide. A couple references. These are just the ICSF manuals. The Application Programmer's Guide. If you know what APIs are being used in your application programs, the Application Programmer's Guide will tell you what hardware you have to have available to support those APIs. The Administrator's Guide talks about the process for loading master keys and making sure that they're available at your DR site. On slide 25, There are some documents on the web. The Synopsis of System Z crypto hardware can give you a good introduction to the functionality that's available on the different KEX. So if you're trying to compare what do I have in production versus what do I have in DR, that document can probably help you. That magazine article, the How to Set Up TKE for Disaster Recovery, that's a little bit dated, but it still applies. The information in there is still good. And slide 26, there are some red books that talk about using ISKLM and the encrypting tape drives and what you got to do to get that environment set up so that you can recover in a disaster. Finally, on slide 27, I'm going to stop talking for a while and let Jerry open up the phones for questions. Thanks.